and Sotney works for Grenada, the Georgian NRM. So I'll be presenting you our use case and why we are looking for a new solution here involving perfSONAR, and establishing the context in which we're doing this new setup and the new measurements and the new visualization we come up with. And then I'll be introducing all that and then hand over to Sotney to do the actual demo of the installation and the dashboard that we can show you. So in the last couple of years, we've seen quite an interest amongst universities in the GEMT area that would like some help from their National Research and Education Network to manage their own campus network. Because their team is getting smaller and they want to still be able to manage as well as possible the campus network. They even coined a new term for that. We are using what we call the CNAS, or Campus Network as a Service. And this new service is starting to being offered by a few NRMs in the GEMT area, but in very different contexts sometimes, because the universities connected to those national network are very different and have some very different requirements. So usually the context is similar in every university, and on the campus network you use a lot of different VLANs to separate the traffic and give different access and privileges to this traffic and be able to manage that better. So we know that perfSONAR can help us look at the performance of the network and of the LAN that's possible of the campus network. But we would like also, with this new solution, being able to look at the performance as seen by the end user. So not only the raw latency and throughput metrics, but also some application level metrics. And thanks to the latest development in perfSONAR in the last years, we now have, for example, DNS and HTTP response time that are available to us by using perfSONAR. And another interesting new feature of perfSONAR is the support of VLANs, or the support of Linux namespaces or Linux VRF that allows you to have a single perfSONAR node doing measurements in different VLANs. So even though you have a large network and you want to measure your network from different vantage points, and you have a lot of different VLAN, you don't need to multiply the number of perfSONAR nodes that you have. And with a good choice of perfSONAR node and the use of VLANs, you can have quite a good coverage of your network. The setup that we decided to use is relying on Elasticsearch, because we wanted to store as many metrics and measurements as possible and build a new type of dashboard. Of course, to have that working well, we needed some kind of automation to deploy the setup and manage the perfSONAR nodes. So we decided on Ansible because it's easy to get started with Ansible. And perfSONAR also now provides some support for Ansible, and with some Ansible roles that you can use. And a few of our NRMs that we were targeting was already using Ansible as well. So the complete setup that we come up with is something like that. So from the perfSONAR nodes, we send the measurements results to Logstash for a bit of processing. It is stored then in Elasticsearch and later presented in Kibana. What we're going to show you and demo you today is two Ansible playbooks that help with that, setting up the ELK central server and setting up the Linux namespaces on the perfSONAR nodes. And from there, we can do different type of measurements, latency and throughput, but also DNS and HTTP response time. So I now hand over to Tsotne for the actual demonstration of those two playbooks.
Hello, everyone. Thank you, Antoine. I will share the screen. So as Antoine said, we have two Ansible playbooks here. Both of them are located in GitLab repository, and one is used to set up the ELK stack, and another playbook is used to set up the network namespaces. I will try to run the first playbook. We can just follow the commands that are described here in a README. You need just to clone the repository, change the directory to the project, and the only thing you need to run the playbook is to define the host. In our case, we will have the virtual machine with IP address shown here. Before we run the playbook, let's check if Kibana is available now. Here, it's not. After finishing the playbook, we should see the Kibana dashboard here. Let's start the playbook. The playbook needs from 6 to 7 minutes to complete, and while it will working, I will just shortly explain how it works. The playbook, Ansible playbook, will install all the dependencies needed to ELK to run. It will install Docker containers. It will copy the configuration files for Logstash, Elasticsearch, and Kibana, and then it will run 3 Docker containers. And finally, it will import the graphs to Kibana. After the playbook will finish its job, you will have a dashboard like this. Here we have already working dashboard, and I will try to explain how it looks like and what we have here. The first visualization is just a representation of IP location, geographical IP location of the IP addresses that are participating in different tests. Here we have Germany, Georgia, United States, and IP addresses from Russia and so on. Scroll down, and here we have the drop-down list with the different filters. For example, this filter is for VLAN 90. You can apply the changes and filter the whole graph only to VLAN 90. You can see that the whole graph is changed. Also, we have here we have a filter of different test types. For example, HTTP test. Also, we can apply, and the whole graph will change. At the right side, here we have DNS response times for different DNS servers and for different namespaces. Namespaces means different VLANs. For example, this VLAN is VLAN 92, and this red line is for VLAN 92 and for DNS server 1.1.1.1. And here is the response time at the left side for this particular DNS server. The second VLAN 93, and the other Google's public DNS server, the default namespace, which means no VLAN we have here, and some other DNS servers here. At the left side, also we have DNS response times. This graph is similar as the previous one, but all the lines are located in the same graph. Here we have top 5 sites which are participating in our tests, and top 5 name servers. For example, you can just click at this DNS server, and by clicking on this, the whole graph also will change. Let's back. In the similar way, you can click on a particular site here, and the whole graph will change. The next graph is HTTP status code and response time. What does it mean? We can scroll to one particular test, and I will try to explain. So this is one test for one particular site, netflix.com. At the left side of this graph, you can see the response time for this HTTP test, and at the right side, you can see the status code, which is 200 OK. So this site was operating well, and the response time was like about 2 milliseconds. It's back. Next is also HTTP graph. Different visualizations are here for different VLANs. For example, this visualization is for VLAN 93, and here you will, and the status code are here. Here you will this green pie is for one particular site, as the response code also here is 200 OK. So next is the DNS servers, also response type for different DNS servers, but this graph is slightly different. Here we have response type for Grena's DNS server. The IP address is here, and the average of all summary of all tests which are going to this particular DNS server, and other DNS servers, for example, Google's public DNS server, and so on. The total number of tasks we have 318. The throughput test is here also for different VLANs. The second throughput graph is here, and you can filter all these graphs by clicking on this. Also, very interesting graph we have for traceroutes, which is a hop count. For example, for yahoo.com, the hop count in this particular time was, for the beginning, it was 15. Then it changed to 13. Then it changed to 14. And with this line, you can determine, or some network administrator can determine that the routing table may was changing to yahoo.com in this period of time. At the bottom we have just the raw data, which is located in Elasticsearch server. This is all we have. Let's have a look at our Ansible test, and it has finished. Now we should have running Kibana dashboard here. All the visualizations from beginning will empty because we have no data yet in our Elasticsearch. And once you will send the data to your Elasticsearch cluster, you will have the visualizations on. And so you can see the same graphs are here. Okay, let's have a look at the second Ansible playbook, which is for deploying the network namespaces. We can follow the commands which are described. Just clone the repository, change the directory to the project, and the only thing you need here is to define the hosts. In our example, we will define our test virtual machines. And the second necessary thing also you need to do is to define variables per each host you have. Variables you should define in the folder host vars. So the variables are the name of the namespace, VLAN ID, the IP address, and the gateway. In this example, for host 1, we have VLAN 10, VLAN 15, and VLAN 20. And for host 2, we have different variables. Let's see if we have VLANs and if we have a network namespaces already. List. So you can see that we have no network namespaces for this particular IP address. And just run the playbook. The playbook will generate different system files for different hosts based on the variables you will define. And you can see that for this IP address we have 3 VLANs which we already defined: VLAN 20, VLAN 15, and VLAN 10. So I think that's all. I will stop sharing my screen.
Thank you, Tsotne. I will quickly take over. So you've seen the demonstration of the two working Ansible playbooks that we have to set up the central server and set up the Linux namespaces there on the perfSONAR nodes. What we'll be integrating in the near future is the actual deployment and configuration of perfSONAR on the same perfSONAR nodes as the Linux namespaces are configured now, and manage the measurements with psconfig amongst this network of perfSONAR nodes. At the moment, the results that you've seen in the dashboard presented you were run manually or with repeatable schedule, but not through psconfig. So all that we have presented today and the Ansible playbooks are publicly available at those URL. And I also invite you to have a look at our perfSONAR Ansible Quick Start playbook, where you have a quick way get you started. Yeah.
We don't see, Antoine, we don't see the presentation because your chat screen is on top.
Okay, sorry. So here are the resources that I was talking about. Yeah, so you can go and check that. And happy to answer a few questions now if we still have time, or meet and discuss with you during the breakout sessions.
Antoine and Satni, you've done such a great job that nobody had any specific questions for your presentations. AJ has asked if the slides will be someplace, and Susan's announced that those will be available in a shared repository at the end of the day or sometime very soon after presentations today. So for everyone looking for those slides, they will be made available. You'll get an email about that, and they'll be on the webpage.